Hi, in this video we're going to solve simultaneous equations where one of the equations is non-linear and we've got fractional terms as well. Now remember, this is the linear equation because if you were to plot it as a graph, it would be a straight line. Linear means straight. And the way you can tell it's linear is because if you look at the terms, the x and y terms are not squared. So you've got 3x, the x is not squared, and you've got this y term, and you possibly have a constant term, a term without a variable in it. So this other equation is the non-linear one. And I know that x and y don't have powers, but it's because specifically you're dividing by the x and dividing by the y. And remember, 1 over x you could write as x to the power of -1. So effectively we do have a power of x. We've got x to the power of -1 rather than this x here, which is just x without a power. It's effectively to the power of 1. Now remember how we solve these kind of simultaneous equations. We substitute the linear equation into the non-linear one. So we substitute this 3x plus 2 into the other equation. So we can see that because y is equal to 3x plus 2, we can substitute that as the y in the other equation. So this y here in the non-linear equation we can replace with 3x plus 2. So let's do that. We're going to rewrite the first equation but with the y substituted for replaced with 3x plus 2, which is what I'm doing here. Okay, now we've got quite a difficult equation here because we've got algebraic fractions. So one way we can deal with this is to combine these algebraic fractions into one. So we're going to do this subtraction. And remember how we subtract fractions, we need to have a common denominator. So if I was to multiply this first fraction, top and bottom, by 3x plus 2, like that, and multiply this second fraction, top and bottom, by x, so this by x and this by x, you can now see that we have the same denominator. So we can now just subtract the numerators. So we've now got 3x plus 2 times 1, which is 3x plus 2, and then we're subtracting 10x, and that's all over x, 3x plus 2. And we've got the minus 2 equals 0. Now, the slightly less messy way of doing this is that you just multiply the denominators. So x times 3x plus 2 is x, 3x plus 2. And you cross-multiply the numerators. So this 1 here is going to get multiplied in this diagonal by 3x plus 2. So 1 times 3x plus 2 is 3x plus 2, minus, and that 10 gets cross-multiplied with the x. So 10x, you can see you've got the minus 10x there. So that would be the way that I would do it myself. And now let's just tidy up a bit. You've got 3x minus 10x in the numerator. So we've got minus 7x plus 2. Let's expand out the denominator. We've got 3x squared plus 2x. And I'm also going to add 2 to both sides of the equation. So I have equals 2 like that. Because now I've got this fraction here. I don't want the fraction. I've got the over 3x squared plus 2x. So I'm going to multiply both sides of the equation by 3x squared plus 2x to get rid of the fraction on the left-hand side. So times it by 3x squared plus 2x. So on the left, when I multiply by 3x squared plus 2x, it gets rid of that over 3x squared plus 2x, just leaving minus 7x plus 2. And on the right-hand side, I'm going to times that 2 by 3x squared plus 2x like that. Now I need to expand that bracket. So we do the 2 times the 3x squared, which is 6x squared, and the 2 times the 2x, which is plus 4x. Now I've got a quadratic equation. I need to get it all to the side where x squared is positive. So I'm going to get it all to the right-hand side. We've got 6x squared. I'm going to add 7x to both sides, so that becomes 11x. And I'm going to subtract 2 from both sides. And now I've got 0 on one side of the equation. 0 over here, which I've just put on the right here. Now, how do you solve a quadratic equation like that? Now, we've seen in previous videos, we could use something called splitting the middle term. And remember, we found two numbers which added to give the middle number, the plus 11, the coefficient of the x term. So they've got to add to give 11. And they've got a times to give the first times the last number. So 6 times minus 2 is minus 12. Now, what are those two numbers? Well, it is 12 and minus 1, isn't it? 12 and minus 1, they times to give minus 12, they add to give 11. So what you then do is you split that middle term into the plus 12x and the minus 1x like that. And let's just copy the rest, so 6x squared minus 2. We do explore this in other videos in case it seems a bit quick. And then remember, we factorise each half. So we factorise the first half and the second half. What can we factorise out the first half? Well, 6x squared and 12x have a common factor of 6x. So we take out the 6x, open a bracket. 6x times what is 6x squared, it's x. And 6x times what is 12x, it's plus 2. Then we leave a bit of a space and duplicate the bracket. And then you think, what goes in this space? What times x plus 2 gives you minus x minus 2? Well, it's minus 1, isn't it? That works because minus 1 times x is minus 1x, and minus 1 times 2 is minus 2. And then finally, just to kind of do it the quick way, whatever this thing in the bracket is your first bracket, and whatever's outside of that bracket is the other bracket, so 6x minus 1. The reason that worked is because I basically just factorised out the x plus 2 as a common factor here and here. But now this is great. We've got a product of two things equals 0. It's nice and factorised. If two things multiply to give 0, at least one of those is 0. So the x plus 2 is 0. Remember, the quick way is just to negate whatever number's here, so that becomes minus 2. And then if that is 0, remember you negate that, so the minus 1 becomes plus 1, but you divide by the number in front of the x. So plus 1 divided by 6, you get x is a sixth. But you could just make each of these things 0 and then solve it. So x plus 2 equals 0, solve. 6x minus 1 equals 0, solve. Right, but we're solving simultaneous equations, so we've got to find the value of x and y, or values of x and y that satisfy both equations. We found the values of x, which will work, so we need to find the corresponding values of y. And remember from the previous videos that it's always easiest to sub that value of x or y into the linear equation, so this equation here, because it's just easier to do that, and you can see y is already the subject there. So y is 3x plus 2, let's just write that up here, y equals 3x plus 2. If you substitute the minus 2 into it, you get 3 times minus 2 plus 2, and that gives you minus 4. And if x is a sixth, you do 3 times that, 3 times the answer plus 2, and that gives you 5 over 2. So y is 5 over 2. And we are done.